Okay, guys, this is going to be our next section. It's actually, we're going to jump to chapter 5, which is going to be over polygons. So we're going to talk about properties of polygons, most specifically their angles, okay? So 5.1 is going to be polygon sum conjecture. So let's review what a polygon is. A polygon is going to be a closed geometric figure in a plane formed by line segments. And so this is all from chapter 1. And so if you can remember back in chapter 1, we defined what a polygon is, and we actually talked about their properties, but all of these are examples of polygons because they're all made up of segments. Over here, these are all not polygons, okay? These are curved in all sorts of ways. This one does not close right here. This one could have been if they connected it with one last segment right here. And then we had two special types of polygons. This one was convex over here. These are where when you draw all the diagonals in the polygon, they're all going to end up being on the inside. So I'll draw a few just to kind of show that. See, diagonal here, here, here. So y'all should know what diagonals are. There's many more there. See, no matter how you draw these diagonals, they end up being inside the polygon. Over here, these are concave polygons. These are still polygons because they're all made up of segments, but they're concave because when you connect this vertex to this one, that diagonal is in the exterior. Same thing with this one when I connect that one to there, and there's more. And then same thing with this star. When I connect these diagonals, if a diagonal ends up being on the exterior, that's called a concave polygon. Okay, so let's go into the investigation. It said, is there a polygon sum formula? Okay, sum of what? Well, that's what we're about to figure out, the sum of something. So this investigation says, find the sum of the angles of convex polygons. Okay, so only convex. Discover this by drawing 3 polygons with 4 or more sides. Then divide the polygons into triangles by drawing diagonals from one vertex only. Okay, so let's do that for now. So we have 3 polygons. So a 4-sided one, a 5-sided one, and then a 6-sided polygon. Okay, so draw those right there. And then it says draw diagonals coming from one vertex only to form triangles. So I'm going to draw one diagonal here, and I can't draw any more diagonals because the other 2 would be the sides. And I'm going to go from here to here. That one can be 2 diagonals. Obviously, this one looks like it's going to be 3 diagonals. 1, 2, and 3. So you can see I have 1, 2 triangles here. I've got 1, 2, 3 triangles here. I've got 1, 2, 3, 4 triangles there. Okay, so I'm going to take you back to the triangle. You guys have been knowing this for a while, but how many degrees are in a triangle? 180 degrees. And so if I have 2 triangles in this quadrilateral, all I have to do is 2 times 180 degrees. Over here, all I have to do is 3 times 180 degrees, and that's going to give me the total sum of all the angles, okay? So meaning this angle, and this angle, and this angle all add up to 360 degrees. 3 times 180 is 540 degrees, okay? And then the last one I didn't do, this one was 4 times 180 degrees. That ends up being 720 degrees. Okay, so I'm going to highlight this number right here, and now you should be able to figure out the number of degrees, the total number of degrees in any polygon. So remember, this one was for the 4-sided polygon. This one was for the 5-sided polygon, and this one was for the 6-sided polygon. So how is this 2 related to the 4? How is the 3 related to the 5? How is this 4 related to the 6? There's always going to be 2 less than the number of sides, number of triangles, okay? And so you should be able to figure it out for any type of polygon now, Okay, so let's fill out this conjecture down at the bottom of the two that we just did. Quadrilateral sum, the sum of the measures of four angles in any quadrilateral is 360. Now don't think that they're all 90, 90, 90. Because remember, you can have a quadrilateral that looks really weird like that, where they're not 90. Okay, so but you should know that all four always add up to 360. And some of y'all probably knew that already. The pentagon, this is going to be 540. That's what we figured out. 3 triangles times 180 is 540. So let's carry it on to this table. Okay, so a triangle has 3 sides, 4, 5, 6, 7, and an n-gon has n number of sides. So how many triangles are in a triangle? Only 1 triangle. Notice it's 2 less. And then we just did these 3, sorry, we did those 3. And so how many triangles are going to be in the heptagon? 5 triangles. And so when you think about this number, that's all you have to do. It's always going to be 2 less. So how many triangles would be in a 100-sided polygon? Well, 2 less, 98 triangles. Okay, so it should be pretty easy. So for n, it's always going to be n minus 2. So what is the sum of the interior? That one you already know. We just did those 2. What would it be for the heptagon? All we have to do is 5 times 180, which is going to be 900. And so for any polygon, any n-gon would be n minus 2 times 180. So the sum of the measures of the interior angles of any n-gon is going to be n minus 2, which n stands for the number of sides, because that's what's shown right here, number of sides, times 180 degrees, which comes from that triangle. Okay, all right. Let's go to the next section, 5.2, exterior angles of the polygon, and then regular polygons. Okay, so what is a set of exterior angles? So I want you to draw this right here. So a set of exterior angles are going to look like this, where you extend this side right here. And then you have to keep it going in that same format. And you don't have to draw the arrows at the end. I just like to draw. Okay, so these are the angles that are a set of exterior angles. I'm gonna highlight them in red. 1, 2, 3, 4, and 5. Okay, so angle 1, 2, 3, 4, and 5 is a set of exterior angles for any type of polygon. So you just need to keep drawing them in that same direction. Okay, so that's what we call a set of exterior angles. They don't necessarily have to be equal, because you can see here, like this one looks, angle 1 looks larger than angle 2. Okay, some might be equal, they can, but they don't have to be. So let's do an investigation with the exterior angle sum. Maybe they add up to a certain amount of degrees. So it says use the given polygons to extend the sides to form a set of exterior angles, just like I just showed you. And then it says use your linear pair conjecture to solve for the measures of each exterior angle and find the sum. Okay, so let's extend each angle first. Okay, so we're going to extend it out that way, and then extend it out that way, and then extend this one down. Okay, so here's my exterior angles right here, this red one, and this red one. Okay, so let's find the actual sum of those. Or actually, let's just write down the number. So linear pair, remember, adds up always to 180, so you may want to get your calculator. So I'm going to put in my calculator 180 minus 28. So this is a 152 degree angle. Okay, over here, 180 minus 62. This one is a 118 degree angle. And 180 minus 90, this is a 90 degree angle. Okay, before I add those up, let's go ahead and take care of this other side over here. This other polygon. So I'm going to extend. And it doesn't matter which way. You're noticing now that I'm going the opposite direction. as opposed to what I did on the other one. So this is an exterior angle, this one, and that one. So let's add those up, or let's figure out the angle measures first, and then we'll add them up in a minute. So this one would be 105, because remember they add up to 180. This one is 90. 128, that would be 52. Those will add up to 180. And then this one over here would be 113. Okay, so now that I have the angle sum right here, or have all the angles, now let's figure out the angle sum. So over here, I want to add 118 plus 152 plus 90. And what does that equal? 118 plus 152 plus 90. That gives me 360 degrees. Okay, let's do the this polygon over here, the quadrilateral. So I'm going to add 105 plus 113 plus 52 plus 90. So 105 plus 113 plus 52 plus 90. Okay, my calculator went crazy. So let me try that again. Wow, I got the same exact value as I did over here. Okay, so I got 360 that the exterior angles add up to, and 360. You think if I were to draw a pentagon that it would come out to 360 again, or would it be larger? Well, if these two came out the same, they all probably are the same. Okay, so for these two I got 360. So for the pentagon, guess what? It's going to be 360 as well. Okay, so it's going to also be for that. And so for any polygon, it's going to be that. And let me show you why. If you were to take these three vertices, let me get a different color. Let's get orange. If you were to take these four vertices and you were to kind of basically like shrink this polygon till it gets super small, they would all end up, all the points would end up at one dot. Same thing here. If you were to shrink all of these to the smallest figure, well, they would shrink to one dot. Okay, well, if they shrink to one dot, think about if you left those exterior angles showing, you would have this one here, you have this one going straight down, you have this one going to the left, and then you have this one going out that way. What do all four of those angles add up to? What kind of shape am I making there? 360. Same thing here. That one, and that one. When you shrink it, okay, when you kind of like make it smaller into one point, you get all three angles in the form of a circle, which there's your 360. So no matter what shape you're working with, if you decrease the size and shrink it, it's going to go to that one point, which creates your 360 degrees. Okay, so no matter what, it's always 360. So do I have okay, so it says using the interior angle sum, how would you find the measure of each interior angle for these regular polygons? Let me go back on your notes. I forgot it had this conjecture down at the bottom. So it's a pretty simple answer. For any polygon, the sum of the measures of a set of exterior angles is always going to be 360. Okay, which we said in the table over and over again. All right, so let's go to regular polygons. So I'm going to highlight that for a second and review what that is. So for regular polygons, remember all sides are equal and all angles are equal. Okay, so we're going to use basically what we just learned, but to find the measure of each one of those. Okay, so Get my pen. I drew a couple of regular polygons with their extended sides to be a set of exterior angles. So it says, how would you find the measure of each interior angle? Well, if we think about it, remember for the 5-sided polygon, there's 3 triangles in there. So 3 times 180 equals 540, which some of y'all will probably end up just kind of memorizing that. So 540. So to figure out each one, all we have to do is take 540 and divide it by 5 angles. And so you'll want to get your calculator and divide that. And so 540 divided by 5 equals 108. So each angle is 108 degrees. Okay, so that's all you have to do, okay, is take the sum of the measures formula and divide it by 5, okay? Let's do this other one over here and go ahead and get that. So how many sides does this have? This has 1, 2, 3, 4, 5, 6, 7 sides, okay? So if it has 7 sides, that means it has 5 triangles in that would be formed with the diagonal. So I'm going to times that by 180. So 5 times 180 900 degrees. So the total angles of a heptagon is 900, and then so I'm going to divide that by 7 angles because I've got 7 congruent angles. And so you're going to get a decimal, and that's okay. So this is going to be 128.57. So that's just an estimate. So each angle is 128 degrees, well, 0.57 degrees, okay? Is it easier to leave it as a fraction? You can, but we'll take the decimal. So what did I do? I used that formula that I already learned, and I just divided it by however many angles there are, okay? So now what do we do for the exterior angles? So for the exterior angles, we're going to do, this one's easy. So what do all of the exterior angles add up to? 360 always. So all you have to do is take 360 and divide it by 5 exterior angles. Okay, in which each exterior angle is 72 degrees. Okay, or you know the linear pair conjecture. This is also a good time to use that because that's what we used earlier. The linear pair, to figure out each one, you can, once you find the interior angle, you just have to subtract it from 180. So that's another way to do that, okay? But if you're just solving for it real quick, you just take 360 and divide it by however many angles there are, which is the same number of sides. So over here, 360 divided by 7 is 51.43. Again, this is just an estimate, okay? So we have a formula for each one. The measure of each interior angle of a regular polygon is found by using either one of these formulas. You can take n minus 2 times 180, which that formula came from earlier, and then divide it by n, the number of sides. Or I like this one, and my kids in the past tend to like this one more. You take 180, remember I described that linear pair, and you subtract 360 divided by n. Remember, the exterior angles always are adding up to 360, so it's real easy to use that, okay? And then the measure of each exterior angle of a regular polygon is found by using your 360 rule. Take 360 degrees and divide it by n, okay? And that's what we just did a couple of times. All right, so if we fill out the table just like we did earlier for these first few polygons, each interior angle, you just take the number of degrees and divide it by however many angles there are. Remember, the way you get these degrees are by taking 2 less, remember, which was the number of triangles. So 5 triangles times 180, that gives me that 900, okay? Over here, to find each exterior angle, that one's real simple. You just take 360 and divide it by the number of sides. Okay, here's that formula again. I only wrote one down, but remember that other one's really good too. Okay, so pause this if you need to fill out the table. Okay, let's do some example problems on how you'll see them on the homework and the test, okay, or quiz coming up. So, how many sides does this polygon have? That's the first thing you want to figure out. 1, 2, it has 5 sides. So a pentagon, if you remember, and if you don't remember, that's okay. How many triangles are in a pentagon? 3 triangles. And then remember, you times that by 180. Okay, it's always 2 less. That 3 is just 2 less than the 5. And so that's 540 degrees. So if all of them add up to 540, really all you have to do now is subtract each one of these angles to solve for that x. So I'm going to minus all of those in my calculator. I need a minus 140, I need a minus 80, I need a minus another 80, and then I need to minus a 130. So I'm going to do that in my calculator. So if you did that on your calculator like I did, you should have got the number 110 degrees. So this angle right here, x, is 110 degrees. Okay, let's take a look at this one over here to the right. What type of polygon do I have? I have a quadrilateral. It has 4 sides. And so the magic number here is that you do 2 times 180, which gives me 360. I know some of y'all will probably have that 360 memorized, and some of y'all probably already have it memorized, already knew that. So 360, I'm going to use to solve for each angle here. Okay, all I'm going to do is solve for x. Actually, let me check something. Okay, so we're actually going to solve for the measure of angle D and the measure of angle A. So what I want to do is I want to use algebra to solve for x, and then I can, once I find x, I can just plug it in to solve for D and A. So I'm going to add these in my head. I have 4 x's, so I'm going to write 4x, and then I'm going to add those 3 values in my head. 32 plus 85 is 117, plus another 60 is 177. So I'm going to take that and I'm going to add, set that equal to 360. Minus 177 from both sides. I'm going to get 183. And then I just need to divide by 4. So x equals 45.75 degrees. And that's a pretty clean decimal, so we're going to leave it like that. And so now, if this angle is 45.75 degrees, now I'm just going to add that into there. So 45.75 plus 85, that would be for angle A. This is 130.75 degrees. And then I want to take 45.75 and add 32. So this is 77.75 degrees. Okay. All right. So there's a couple problems with polygons. Here's some more polygons, maybe perhaps a little bit more challenging. What type of polygon do you see right here that I just put a star on? This is going to be a regular polygon because all of these angles are equal. Okay. So if all those angles are equal, you remember that there's 3 triangles that are formed in a pentagon. So I'm going to times that by 180. I get 540. Again, I know some of y'all will just have that memorized, and that's fine. And so what is A going to be? I'm going to take 540 and divide it by 5. I get 108 degrees. So A is 108 degrees. To solve for B, you guys should know that this is a linear pair right here. So if this is 108, that means B must be 72. So B is 72. So how do I work my way over here? Well, over here is also 108, so that means this is 72. And so what type of triangle is this if 2 angles are equal? These are isosceles, okay? Or this one is isosceles. So that's 72 and that's 72. To figure out the C, I can use my 180 rule to figure that out. So 72 plus 72 is 144. 180 minus 144 is 36 degrees. Okay, so this one is 36 degrees, and then I can do my 180 rule, or if y'all remember the exterior angle sum, remember this angle out here is the sum of these two, so angle B is 144. Okay, this one over here, I'm going to solve for angle 1 and angle 2, and all that is given is a set of exterior angles. So what is the sum of exterior angles? 360. Remember, that's the easy one. So you want to add all of that up and set it equal to 360. So I'm going to add all the x's first in my head. I have 8x and 6x, 5x, and then 1x here. So 8 and 6 is 14, plus another 5 is 19, plus 1 is 20. So I have 20x. Okay, now let's add all these constants. So I'm going to start over here with a 10 and then just work my way to the left. So 10 plus 10 is 20, plus 60 is 80, plus a 5 is 85, plus a 10 is 95, plus 15 is 110, plus another 75. What's 110 plus 75? 185. And so you set that equal to 360. Minus 185, I get 20x equals 175. Let's just be sure, because sometimes I do my little mental math incorrect. 175. Divide each side by 20. This is all algebra. So x is going to equal 8.75. Okay, so we need to use that to solve for angle 1. Notice, again, we have a linear pair here and a linear pair here. That's how you want to solve for angle 1 and angle 2. So I'm going to plug in 8.75 for x. So this one, I'm going to do down angle 1 first. So I'm going to times 8.75 by 5. I get 43.75, and I'm going to add 10. So this angle out here is 53.75 degrees. So to get angle 1, I just have to subtract it from 180. So angle 1 is 126.25 degrees. So angle 1 is 126.25 degrees. Okay, and then angle 2, let's do the same thing. Remember, x is 8.75. And I'm going to times that by 8 right there. And I'm going to add 10 to that. 80 degrees. So this angle out here is 80 degrees. So what does that make angle 2? 100. And there we go. So that's using the exterior angle sum. All right, last problem for the day. It says, how many sides does a regular polygon have if an interior angle measures 144 degrees? Okay, so I have this polygon, so I'm going to start drawing it. I don't know how many sides it has, so I'm going to kind of put dot, 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 and a question mark. Okay, it says an interior angle. Now remember, all of these are equal. Okay, so keep that in mind. They're all equal, and each one is 144 degrees. All of these are 144. So it says, how many sides does it have? We don't know how many sides it has. All we know is that, okay? So I'm going to show you the easiest way to do this, okay? Remember, what was the easy thing we learned today? The easiest thing we learned today was the exterior angle sum. So if I extend this exterior angle, I should be able to get that. Remember, they're all the same. Okay, that's an exterior angle and that's an exterior angle. All of these are exterior angles. Well, if the interior angle is 144, what does that make each exterior angle? I'm going to take 180. I'm going to minus 144 from that. Each exterior angle is 36 degrees. Okay, well, you know the sum of all the exterior angles. What's the sum of all the exterior angles? 360. So if I take 360 and I divide it by 36, what does that give me? That gives me 10. So that means there's 10 angles that are going to be a set of exterior angles. Well, if there's 10 exterior angles, then that means there's 10 sides. So what type of, how many sides does it have? It has 10 sides. And that's the easiest thing to do, is work with the exterior angles always, okay? All right, there is a longer way to do it by using the interior angle formula, but trust me, the exterior angles is the best way to go. All right, and that is it.